为什么？
他要记录，
它跟车有什么关系？
他每天有关系啊，放回去了。他毕竟要车不是他车。
Yeah, I don't like that example for, let me put an example. For,
等到最后，
okay, yeah. Cell phone. Based upon your understanding, how many components required for the final assembly of a cell phone? How many components are required or produced by different vendor, by different manufacturer in order to assembly an end product cell phone? How many components required? 100? 200? 300? What do you think?
1,000.
No, 1,000 may not that many, maybe 100, right? Okay. For example, the TFT LCD, polarizer, the camera module, and then connectivity module, Bluetooth. Yeah, so many, right? Okay, for example, 100. Then, for this guy, there's a manufacturer who are manufacturing the camera module. Okay, so if the camera module producer, they follow Three Sigma principle, for example. If the camera module follow, their manufacturer or production practice follow the Three Sigma module, so their conforming rate going to be, what is the conforming rate? If that guy follow the Three Sigma module, 99.73, right? Okay, okay. So the Mr. Yellow producing the connectivity module or Wi-Fi module, he also follow Three Sigma principle, so it's also 99.3. So totally how many components? 100? 99.3. Percentage. So that is going to be 0.9973 raised to power 100, right? So for each component to be conforming, either one non-conforming, that cell phone going to be defective. Either 1 out of the 100 or 2 out of 100 or 3 out of 100 components are defective, then that cell phone going to be considered to be defective. Cannot be sold to the customer, not at all. As long as every component is conforming, then it can be checked perfect and shipped to the customer, right? So do you know what this number is? Would somebody calculate this number for me?
0.7631.
So what does this number mean? What does this number mean? 0.763. That means you produce every 100 cell phone is going to be 24 return. You're going to be rejected. You produce every 100 cell phone, 24 will be non-conforming. Do you think it is a good quality? No. So the Three Sigma principle for every component, that will be okay. However, for the entire supply chain management, it's not going to be good. Do you get it? That's why we need a Six Sigma principle instilled into the supply chain management in manufacturing practice. That's why we need Six Sigma. Get it? this is an example. This is about that. Why we need. This is a kind of quality improvement. The instill the quality concept of Six Sigma into the product. 手机收起来，手机收起来，手机收起来。OK， 好的。不要浪费你父母亲的钱。OK。Then initially in manufacturing, so there's a high variety application in credits like the banking. Okay, so this is quite complex. So before close out, the 3:30 in the afternoon. So there's a so tedious and consuming transaction to be closed out, and the finance and the public sector and the services. Then from the Six Sigma, then it moves to the design for Six Sigma. Design for Six Sigma. So only so much improvement can be brought out of the existing system. So we add this design into the Six Sigma principle, starting from the phase of the design. And the new process design, so this is the new one. There's an augmented to the original Six Sigma principle, the new product design, and perform the re-engineering. So typically re-engineering so just create the bondage between the R&D and manufacturing. So just link these two sectors together. So R&D typically there's for the design the product. What is it? The purpose of the NFG, manufacturing the product. So need to have a facilitate further communication. So, okay, so this is some example commercial from a Six Sigma. So this is DMAP. This is a must learn and the must know. And so a disciplined and analytical approach to process and the product improvement. DMAP, specialized rule for people, champion, master, black belt, and the black belt and the green belt. This definition, how experienced you have done with the Six Sigma practice. Then it is a top-down driven from champion down to each business. So this is a champion. Then the master, black belt, and the green belt. So champion considered as a general manager. The master black belt considered the department manager, and the black belt considered a section manager, and the green belt considered as a senior engineer. So the BBS, the black belt and the master black belts have responsibility for the project definition, leadership, training, monitoring, mentoring until the team facilitation, and evolving the 5-step DMAIC is also pronounced as a DMAC. Define, measure, analyze, implement, and control. So I think I've done the 6 Sigma. Okay, let me say how does it work for every level. So page 32. Page 32. So this is leadership team, business unit executive or appropriate staff, typically known as the top management. The project champion black belt. A project champion is known as a business leader with overall project responsibility. The master black belt is a technical leader or technical executive or domain expert, expert trainer or coach. Black belt is also known as a leader directly involved in the project activity. So going to define what is a KPI, OKRs. And green belt, project leader or black belt team member. This is a member of the team. And the team member and the supporting staff from the human resources, finance, accounting, inventory, or design, or the facility maintenance, or equipment engineering, something like that. Okay, then design for Six Sigma. So this is the diagram matching product requirement and the production capability in PFSS. The taking variability reduction, or we try to focus on these two words, reduce the variance. Upstream, so since sometimes just the variance is present downstream in the pipeline. Downstream, that means 下游. Typically find, wow, how come the defective at the outlet of the pipeline? So we try to trace upstream to the origin of the upstream of the pipeline. So that's why we call. We take in variable reduction upstream. And then from the manufacturing into the product design. So first of all, what kind of concept of the R&D have to have the product design? They get the response or get the feedback from the customer or CPQ, so VOC. So what VOC is? Gentlemen, VOC. What VOC is? The voice of customer, right? Then what is CTQ? Okay, what is CTQ? CTQ, gentlemen? CTQ. What does CTQ mean? 班长，回家不念书就这样啊？你回去有没有念？没有啊，当然没有啊。What is CTQ? Critical to quality, right? Critical to quality. So permit focusing of the effort, permit global optimization explicitly show the customer the cost of requirement, show the specific area where the process improvement is possible. So going to orient it or align the capability option, then we're going to move or deploy the requirement downstream. Let me say it again. So we're going to align the capability upstream and deploy the requirement downstream. So CTQ parameter design like a Jinichi Takuchi, the robust parameter design.
Critical to quality.
The robust parameter design. That will be addressed later. Then subsystem parameter, component parameter, part characteristic. So when we go from the upstream to the downstream, there's a more on-site operation, the more shop floor. You want to shuffle. Okay, DFSS matches customer need with capability, mean and variability affect the product performance and the cost. So we need to go upstream to orient it or align the capability toward the design. Consider mean variability in the design phase and process capability impact the design decision. So there's a capability index to be introduced in the later section or the later chapter, CTK, and CPKN, no, CPN, I'm sorry, CPN. Now at capability. Capability indices. Okay, DMAX solves the problem by using Six Sigma tools. So it is always a problem-solving methodology. However, to be honest, don't blindly trust the DMAX going to solve every problem you face. No possible, not possible. So, however, if you understand what is the essence of the problem, what kind of project you're going to implement, and what kind of defect that occurred, then closely related to the Schuhart cycle, use this method to solve problem DMAIC. Yeah, let me say something. First of all, define the problem. What is the template? Measure, how can you just take the measurement? What is the metrology data? What is the KPI? What is OKR? Analyze the costing factor of the problem, Ishikawa diagram, or you just use a Pareto chart to classify what is trivial many or critical field or trivial many. Then improve the process removal, remove variation and the non-value added process activity. And finally, we try to control the process, so problem. They never, ever happen again. Once we solve the problem, we control it. It will never occur, never again. Okay, then Lin. What is the limit? What is the limit? Limit. This is cost effective. Somebody also defined the limit as the resources effective. The resource consumption effective or resource efficient. That means we use exactly amount, exactly magnitude, or in the tiny manner as possible. Exactly. Not too many, not too less. Not too many, not too less. Exactly. Over there. So originally, this is known as lean in the food. Original meaning is the food. In food, that's skin, right? So focus on elimination of the waste. That's why we talk about 6R. So let's recapitulate what is 6R are. Recycle, repair, refuse, reuse, and reduce and recovery. Yeah, 6R. Then long queue in process inventory. So I'm going to reduce that. Reduce the long queue the long queue in process inventory is known as WI. You did learn the operation and production management. So what does WIP mean? What is WIP? Working process, right? We're going to reduce that and inadequate throughput, something defective or downgrade. We're going to reduce the downgrade. What is the downgrade? Downgrade. What is the downgrade? Miss Chow, what is a downgrade? Can you understand that? Yeah. And rework, and the non-value added work activities, the main use of many of the tool of the operations, research, OR, and the industrial. Okay, this is a process, so we're gonna skip that. This is about the queuing theory. Who is the instructor of your OR course? Liu Jianhao or?
Yes.
Okay, two semesters, both?
Yes.
Does Professor Liu teach the queuing theory? No. 等候理论有没有教？
没有。
第二学期教什么 ？OR 第二学期教什么？
整数规划跟这些动态规划。
Okay, link systems. Okay, I think that'll be done. Okay, this is. Okay, page 34. Okay, the Six Sigma DMAP, eliminate defect, reduce variability to make the process capable. Variation reduction, then enable then predictability, visibility, efficient capability, and accuracy. For the link, eliminate waste, improve the cycle time. What does the cycle time? What is the cycle time? What do you mean the cycle time? Lady? If this is raw material, we just press into the production line. The starting point of the raw material had come into the pipeline until the end product shipped to the customer. In between, that is called the cycle time. 你们生管到有没有学？修过了没有生管？
对，这学期是刚学。
Then, eliminate, improve the cycle time. Then, lead time. What is the lead time?
那个
So, for
另外
example,
一个班导，以前就是
for example, let me put this example. Okay, I'm producing the cap of the bottle for this gentleman. So he always expecting I deliver amount the order of the cap to him for the final assembly. Then, when he places an order to me to the sub-assembly of the cap, then until he receives the interval between he placed an order, he received the order, the time in between called the lead time. Called the lead time. 前置时间，他下了订单给我，到了我给他中间的时间就叫做前置时间。Okay, lead time. Yeah. The lead time we would try to reduce the lead time to cycle. And the flow mapping with elimination reduce cycle, the WIP working process. So in the same company, the three guys, the process A, process B, process C. Okay, there's a flow. This is called a flow chart. And process C always expecting the sub-assembly from the process B. Process B always expecting the sub-assembly from the process A. So in between, there's a lead time between A and B. There's a lead time between B and C. That's it. So try to reduce the working process. That is to reduce cycle time. I'm the customer, he's a guy. Okay. I'm the customer, he's a vendor. There's a lead time. In the same production line, ABC, there's also internal lead time as well. So DFSS design predictive quality into the product as early as possible in the design phase. So requirement, allocation, and capability assessment, robust design. This is I mentioned. Yeah, somewhere around here, right? Robust parameter design. Right? I put down here, robust parameter design. In here, robust design, predictable product pattern. So supply chain quality, so I'm going to skip that. So supply chain is out of scope, so should be covered by Professor Che. Okay. Che is an instructor of the production management, right? Okay, he will cover, I hope. Okay, supply chain management, so that will be end of the, the legal is out of my library. Okay, let me see this also. No, return management, supply chain hold, Professor Che will cover. Supply chain, yes, return management cost attribute, that means if there's a complaint, customer complaint, how can we just manage the return? And product, okay, the product report. Then, okay, important. This one. Internal failure cost and the external failure cost. If the cost incurred within the organization before the product or service shipped to the customer, that is called internal. If the product are already out of the office during the shipment or to the distribution center, toward customer, that is turn, external customer, external failure cost. Like a scrap rework, retesting, retrial, failure analysis, downtime, that happen in the office. happen in the manufacturing site, called internal. External, the problem already occurs, ship to the customer, complaint, and the return, warranty, liability, and the indirect cost, that is called the external process. And the prevention cost, like the project planning, there's a done before, engineering, product review, burning training, that's called the prevention cost. You gotta do something to avoid possible failure to occur. And the appraisal cost, that means you need to do some measurement, appraisal or assessment in order to assure the quality level. Then inspection, and the consume, and the maintain accuracy of the test, something like that. We call it assessment test. Assessment cost. Okay, so legal aspect of the issue. Okay, then we talk about what is a liability. Liability. The legal, that means there's with reference to law. So the product liability exposure, like you use a Samsung iPhone Note. There's an explosion of the battery, so there's going to be a liability problem. The legal. So product exposure concept, strictly liability responsibility, both manufacturer and the seller and the distributor, and the advertising must be supported by the valid data. Before we sell the cell phone to the customer, we will the customer should be fully instruct how to operate in the normal condition. Like the watch, when you buy that, okay, how deep, how much the pressure you will endure when you do the diving. Okay, so this is a liability. Okay. Or the bottle. So what is the maximum temperature this bottle will endure before it emitting dangerous material? So this is a legal aspect about the liability. So I think I'm done. Right. So end of the chapter 1. Then we move to the chapter 2. So I think that'll be the day for today. Okay, remember we're going to cover. Okay, please remember, gentlemen, just bring the slide of chapter 2 and chapter 3. So chapter 2 is going to be a quick chapter. So I'm going to move forward to chapter. So we're going to cover chapter 3 partially next time. So bring the slide of chapter 2 and chapter 3 as well. Okay, see you next week. Remember to submit homework. There's a by group of the 2 people, 1 female, 1 male, as possible.
Okay.
Please. Try to find a better mate.
好，那个。